Okay, we are almost at the end of this thing. Okay, and today I will you will be doing most of the work. So this was about substructure. Okay, and substructure is up to what level? The ground, foundation, underground. What's the right word? Ground and the underground. So, what do you mean by the ground? When we say ground level, what does it mean? Or when you are saying ground level, what does it mean? You're saying ground under the ground. What is the ground level?
Ground of the foundation.
Up the foundation. Top side of the foundation is ground level. Yeah. No. Anybody else? Ground level means what? What you are mentioning as ground level as the end of this structure. Top of. Show me here. Top of what? This is not soil. This is what? No. Floor. Okay. Because you have seen the drawings where they are showing the ground level and the floor level both. And they are two different things. Okay. So they use ground level for natural before construction. And floor level is a constructed part, the constructed level. Okay. So the main difference is there's a lot of difference, obviously. Clear? Okay. So we are not doing it till the ground level. Ground level will not exist. Okay. We are doing it till the floor level. Okay. Then what are the things included? In what sections you will find these things? Okay. Activities included, the workflow, and then we have discussed each of the items. Okay. With whatever we are doing, whatever we are excavating, the filling is included. It is part of it. Okay. And this drawing basically shows the different levels. Okay. You can see the ground level, you can see the floor level. Okay, the foundation level, the excavation level, and so on and so forth. So all of them are different. Okay, and we start with the removal of topsoil, which is very important if you have grass or vegetation on the plot. The section of the NRM bulk excavation to reach to a common reference. Okay, reduced level. And then we fill it then everything is measured from this after the bulk excavation. Okay, the NRM. Okay, you can see the bulk excavation. Okay, the reduced level. Okay, and so on and so forth. Some examples, yes. Until the removal of topsoil. So you remove this was the ground level. You remove the topsoil. This is your bulk excavation from here till the reduced level, not the binding, not the blinding. Till what reduce your reference level? Till your reference level. No, it's over the blinding. Is it here? No, it's not here. Wait. Yeah. This is my bulk excavation level. Okay. Like I will do the excavation till here. To the bottom of the topsoil. So topsoil is removed. Okay. So for example, from here till the existing ground level was, let's say, 0.5 meters. And you remove the topsoil 150 millimeters. So your bulk excavation will be 0.5 minus 150 millimeters, the height. Okay. And the area, as I mentioned, the topsoil and bulk excavation, the area is same. The area remains the same. Okay. Wherever we are talking about excavation, the filling is included. The brickwork and the block work. External walls are usually brickwork and internal walls are block works. And you may have some arrangement like this where you have two faces of the wall, one with bricks, the other one with blocks. Okay. And damp proofing. There's damp proofing course, which is under the wall, and there's damp proofing membrane, which is under the floor. Okay, we have looked at all these examples. Okay, and basically what we discussed last time was what girths, what perimeter we will take for each type of excavation and for each type of quantity. Okay, so for topsoil and bulk excavation, what is my edge? Up to what I calculate the area? For bulk excavation and topsoil, it was same. Up to what? Huh? Projection of the footing. Okay, the external projection of the footing. Same thing for topsoil and bulk excavation both. Okay, then we have the excavation, which is for the footing itself. Okay, and what length do we take for the footing? Calculation of excavation for the footing. If it is a strip footing or a trench foundation, what length do we take? Yes. I want to calculate the excavation for the footing or concrete for the footing. The length will remain the same. Okay, so what length is that? I know the height, I know the width. You can see it here, right? Now what is my length? Length is area. Very good. What point of the wall? What point of the wall? Inside, outside, center, center. Okay. If your footing is under the walls, like a trench footing or a strip footing, we'll take it to the center. Okay, center line. Okay, same thing for the, if your wall is one unit. Okay, the example which we did, the wall is made up of three things: external, internal, and the cavity. So we had to calculate for each one of them separately. But if your wall is one unit made up of one block, okay, from one end to the other end, then the center line of the footing and the center line of the wall is same. Okay, so it's a center line basically. So apart from the topsoil removal and excavation, apart from that, everything is done from center line. Okay, whatever we discussed for substructure, everything was done for the center line. Okay, the concrete, the excavation for footing, the block work, the brick work. Okay, center line of that thing. Okay, center line of that object. Okay, so we did all that. Which one was this? Is the one which we left, which was left. Okay, so the first one is the ground slab. Okay, the ground slab. Okay, it is made up of concrete, as you can see. It's made up of concrete. The type of cement is given. The strength is given, and the size of the aggregate is given. Okay. In the previous lectures, we have seen this information written in a different way. Somebody remembers? How did we see it? The information which is written in the brackets here, in the parenthesis. It was written how? Anybody remembers? You see that the ground floor slab, they have given the description of concrete in the brackets, right? In the parenthesis. Okay, writing everything. How did we write it earlier in the previous lectures? Huh? Yeah, in NRM2. How was it written? NRM2 doesn't give the description itself. It tells you what you should write. Yes. Numbers, how? So what do I write? We are talking about concrete only. Yeah, concrete description. Yes. Yes. So we wrote it simply like this. Okay. We didn't write the units, we didn't write the size and so on. Yeah. Okay. So and horizontal work less than 300 millimeters, this is from NRM. Okay, so you can see number 3 marked there with red color in the drawing. That is my ground slab. Okay, that is my ground slab. Now, which girts we will use for the ground slab? Internal, external, or center line? Center line, internal. Somebody please say external. External. Why? Never that one thing. Yes. Okay, if you have to give one answer, then this one answer, then external. Okay, you have to use internal. Yes. Internal girth. Okay, you will use internal girth for the slab. You will use internal girth. Okay, the internal diameter. Slab, ground slab, as well as first floor slab, second floor slab, whatever slab. Okay, and you will see it in the next lecture, in the next coming slides. Okay, so the internal are directly given. No base calculation required here. Okay, they have given us the internal dimensions. Okay, so this into this 0.15 is the thickness of the slab, which you can see this. There's nothing. There's nothing tricky here. Okay. Yeah. Now we will use the same area to calculate the hard core. Now remember we said we did bulk excavation, right? Okay. So in some part of the bulk excavation, you filled the concrete for footing and the block work and dam proofing and so on, right? So this is filled. The rest of the plot is empty. Okay. And where is this rest of the plot? Under what? Under the slab, right? Okay. Slab is on the ground, right? And you did excavation to the reduced level. Okay. So the excavation which was done for the walls and for the footing, we already filled it. Okay. So the remaining thing is the excavation which you have done and it is under the slab. So there is nothing under the slab now. Okay. So now we have to fill it. And how much I will fill it? The same as the area of the what? Slab. Okay. So that's why you see the bracketing over here. Okay. But we are taking the area. Keep in mind. We are taking the area, not the volume. Okay, not the volume. Because sorry. Yeah. But here you cannot take the same thickness. Slab, concrete. Slab concrete is not measured in square, cubic. Slab concrete is cubic. Unless you have a slab which is precast. Okay. But the point is, this bracketing is just showing the area. Okay. Because the thickness, hardcore, you have to go back and check what was the excavation level. To tell what level you did the excavation. Okay. It could be 150 millimeters, same thickness as the slab, then fine. But normally it's not the case. Okay, it will not be exactly 150 millimeters across the entire plot. Okay, so the bracketing, the point which I was raising here is the bracketing is showing the area same. Okay. Now read here. This is also something very interesting and good. If you read the description, what they are saying. This applies to what? Number 1. The description of number 1. What are they saying? Sorry? No. This. What are they saying over here? Imported means I will bring it from somewhere. Okay, I'm not backfilling. First thing, okay, there's material and it's hardcore. Hardcore is not loose material you fill that. Okay, hardcore means you need something strong. Okay, number two, right? Number one, sorry. You see something like this. This is not natural soil, backfilled. This is something strong, made up of thick aggregates. Okay, so first thing is the material is not backfilling. It's something which you bring from somewhere, and strong material. Okay, what else? What else does it say? It's hardcore, fine. In layers. Huh? It should be compacted in layers. Okay, so for example, I have a total of 0.5 meters of hardcore. I'll not put the entire 0.5 meters and then compact it. Yes. Okay, and the same thing applies for roads as well. Okay, or any type of filling. Even if you are backfilling, the natural soil is not hardcore. It's just natural soil which you are filling back. Okay, so you excavated, you did your work, some places empty, now you are filling it back. Okay, now let's say this filling is 700 millimeters or 800 millimeters. You will not put the whole thing as one layer. Okay, you will make it into small layers. Okay, because compacting small layers is more efficient. Okay, if you make it into a big layer and do the compaction, there will be still some air voids left. Some gaps will be left. Okay. And once your building is operational, once your road is operational, what will happen? Extra load will come, right? Okay. Or once you finish the obviously, you will do the filling and then you will do the slab, right? Your slab has the load. Okay. And then you will have the load of the other floors and you have the load of yourselves. Right? You're watching that, right? So this extra load will do what? Now you did not do the compaction properly at that time. Now this extra load will do what? It will further compress. Okay, it will cause what they call as, I forgot the word. You get that, a settlement. Okay, it will settle the soil now. But now settling is dangerous because your structure is already there. You want it to remain straight, right? You want it to remain straight and stable. Okay, so we cannot allow this. So whenever we are doing filling for anything, for building, for roads, whether it is hardcore or whether it is soil or backfilling, weak material, strong material, does not matter. Filling has to be done in small layers. And a small layer doesn't mean, okay, let's do 150 millimeters now and go home. Layers are so that you can do the compaction. Okay, you will do the compaction. So it is because of the efficiency of the compaction. Okay, so the compaction is most efficient when you are doing it with small layers. So this is it. And the last thing which you very smartly skipped was this one. Okay, 0.5 meters. Okay, so this description applies to the filling which does not exceed 0.5 meters total. Maximum is 0.5 meters. It could be 0.4 meters. It could be 0.1 meter. So anything up to 0.5 meters is this. Anything more than 0.5 meters, go back to NRM and see how it is done. Okay, most probably you will see the change in this 150 millimeter thick layers. Okay, the layer size may change. Okay. Then we have damp proofing membrane. Okay, you can see it over here. It's like a sheet. Okay, which is under what? Under the slab. Okay, and for slab we are taking the internal girth, right? So internal girth is taken the same area, and you have the specifications mentioned here. Okay, that obviously the width is more than 0.5 meters, right? Okay, and this is the material and the thickness and so on. Okay. Clear or not? Any questions? Okay. So you guys have been listening to me since last two lectures. We haven't done any calculations. Okay. So what we will do is now, like I said, you will be doing this. Okay. So make groups and you start with that. Huh? No, I don't want to.
What's this?
Huh? I don't even know magnet.
What's the? What's this?
What?
What's this?
Watch this. You have to calculate the topsoil removal, the bulk excavation, and the footing excavation, and the concrete for footing, and the block work, and everything, and everything.
Then we go, right?
Yes. Now you do it in 5 steps.
Possible.
Yeah, you finish early, you can leave.
Just
I will tell you your mistakes. My favorite job. That's why I don't need
Before,
Yes,
should we go as the calculation sheet?
yes. I'll tell you what you do. Maybe it's in you.
What's the? Nice area. Not working.
What is not working?
I said cannot use the proof.
Listen on.
Yes.
I'm
Yes, it will be cubic meters. Cubic meters. The depth is given somewhere.
Yeah.
200 meters.